Okay guys, so welcome to the challenge number 5 of matrix series. So today's challenge is quite interesting as it is one of my favorite question. The question is that if we are given a chessboard which contains p number of rows and q number of columns which are not known to us and will be given by the user, then in how many ways a rook, or we can say hathi, can go from the left bottommost corner to the right bottommost corner. It's actually the box one, it's not corner, it's box. Okay, so let me give you the details of the question. So the function will take two inputs, which will be the row and column, and it will give the number of ways it can go as the output. Okay, and one more thing, the rook can't stop in middle of a line and then just again go the straight line. It can stop middleware, but it has to turn then. Okay, and it also can't turn to left and bottom. It has to go only right or up. Okay, okay, and now also we have to use recursion only. We can't use iteration. Okay, so uh, let me tell you how this question is. Okay, so this is our rook, as you all know. It can only go in this plus sign, either forward or backward or left or right. Okay, these are the only moves it can, and it can move any number of ways. Okay, so this is where our rook is currently now. This is a 8 by 8 board, but we have not specified any number of rows and columns here. We have to give it for a general formula. Okay, so if this is here, then we have to go here. Okay, and we have to find the number of ways it can do this. So this is a question in which we will use permutation combination, but we can't use the formula directly. So we have to go by recursion. Okay, so so it can go like this, it can go like this, or it can go like this, but it can't be like this, then this, then this, and this, something like that. No, because it will be counted in a single way. Okay, we can't say that it is counted in multiple ways. Okay, that's the main thing. Okay, so the main point is cool overall that we have to, it has to cover q columns and p rows. Okay, so overall he has to cover q columns and p rows, the rook. Okay, and if we consider the left bottommost point as the origin, then the destination is at p comma q. Okay, so if we want to solve this question, we have to give it as a, we have to take the board as an xy plane, and we have to consider the left bottommost corner as the origin, and then number the boxes by p comma q. Okay, or I comma j. So the number of ways to reach I comma j box, I comma j is a random box, and to reach that box, we can, what we can do is, the number of ways to reach I minus 1 comma j plus ways of I comma j minus 1. Like assume that, like if this is our chessboard, or like any random box, and like let's say this is a 2 comma 3. Okay, so if we want to reach there, and if we are here, then to reach here we can come here either by this or either by this. We can't come here from this, because if we come from here from this, then what we are doing is we are actually crossing this path and then coming here, right? And which I have only considered as one. So if we are coming to, if we are coming from here, okay, so let me explain it in a more simpler way. If I say that we have to go from here, and if you say like we can go from here also, then if we counted the ways it go from here, it come here, we have already counted it from here, right? So it doesn't make any more sense to, like, it can't, I said already that it can't stop here and then go like there. It has already come like this. Okay, so if we consider from this, we have already considered that it has come from there and then it is going there. So we can say that for any number of matrix, what we can say is that if we want to come to I comma j, then it can come only from I minus 1 comma j or I comma j minus 1. Okay, that's the only way to do this. So this was our main algorithm line, or you can say this was our main catch. If you got this, then we can simply make the function. Okay, so that's for the explanation. Let's get into it. Okay, so first of all, we will define our function as the output will be y and our name will be ways, my favorite name. Okay, so let the input arguments be p and q respectively, where p denotes row and q denotes column. Then we will write our main argument, that is the ways to go to I comma jth box is equals to the ways to go to the I minus 1 comma jth box plus में the way to go to the I comma j minus 1 box. Okay, so this was our main line, and then we will simply just put it in if and else statement. But before that, to stop recursion or to terminate recursion, we need to add some base conditions. These base conditions in this case are three, which is the one is that if p is equals to 1 and q is equals to 1, then we can say that the y should be 0, which means that if the starting box and the last box is same, which means if there is 1 by 1 box on this chessboard, then there is only 0 way, because we know that if the man is already standing on that place, then how can he go there? No way, right? So the second case should be if p if set else if I am not coding here, right? So if p is equals to 1 and q is not equals to 1, then what will we do? We will say that y is equals to 1, because no matter how far from the starting point the block is, if it is in a straight line, then we can say that it will only take one step for him, because it can't stop in the middle of somewhere, right? It has to go in the straight line. Okay, so and the third case is just the opposite, that if q is equals to 1 and p is not equals to 1, then in this case also y is equals to 1. So these are our three base cases which will help us in stopping the recursion, and this is the main statement that will happen if none of these cases are followed. Okay, then we will just do the formatting and all those things, syntax, and then the main function we will get is something like this. I have already made it here. So as you can see that this is the AND operator, this double S, and this is the equality function, and this is the inequality, and here are the main our line. This is the main line our we have written here also. So let's try our function out. If I say the way is to go to the 2 by 2 matrix, then the answer should be 2, right? Because we can go either right and up or up and right. So the answer should be 2, and as you can see the answer is 2. If I say 2 comma 10, the answer is 10. If I say like 10 comma 10, then it says 48,620. So which means that there are more than 48,000 of ways to cross a 10 by 10 matrix. So that's it for this video. I hope you liked it. Bye.